All right, so sometimes a number line helps with this. So negative 2.75. Here's negative 2.75. So what's the greatest integer that has to be less than this? That's why I can't jump up to negative 2. So this kind of creates a wall, right? What's the greatest integer that is less than that? Negative 3. Okay, so that's the answer to A. All right, just got to plug in 3. What's the greatest integer less than or equal to that? This one's going to be 3 as well. I'm sorry, not as well. That was negative 3. All right, so using the number line again, taking negative 4.8, adding 3 gives us negative 1.8. So negative 1.8 is approximately here. So what's the greatest integer less than that? It's negative 2. So I was thinking go to the left of the number line. Whether it's positive or negative, you follow that progression. Okay, so 3.4 plus the 3 is 6.4. Greatest integer less than 6.4 is 6 for this one. Okay, so piecewise functions, it's really just two graphs in one, and they're usually kind of like chopped off because there's a restricted domain. So we're not graphing 3x plus 3 for all numbers, or negative infinity to positive infinity. It's from 0 down to negative infinity. Okay, so the graph is going to be kind of chopped off. So if you're going to use the table, I'm going to give you two approaches, and you can pick. If you're going to use the table, start by plugging in values that satisfy this domain. So for y equals 3x plus 3, just kind of start one line at a time. Why don't we throw in some values that are less than 0? Include the endpoint, though. We want to always start at the endpoint. So 0 and then some other numbers less than 0. Negative 1, negative 2. Okay, you got some flexibility there, though. If you want to do negative 3 and negative 8, go ahead. Okay, so just remember, even though it says less than 0, and we started at 0, it's because we're going to put an open circle here. We've used that rule quite a bit over the past few years. When there's not a line underneath it, we keep it open. When there is a line underneath it, x is greater than or equal to 0, for this next line, we're going to make this one closed. So I'll mark that right now as closed circle. Closed coordinate, if you will. Okay, so now we just have to evaluate this and then plot the points, and we're going to have our graph. So I'm plugging in 0 here, 3 times 0 plus 3, so we end up with 3. Right? I guess if you want to show the work at least once, go ahead, but it's pretty easy work to do in your head. So when x is 0, y is 3. I'm going to go ahead and plot that point right now so you kind of get an idea of what's happening here. So at 0, 3, I have an open circle. Make it nice and big so you can tell it's open. Okay, let's go on to negative 1. 3 times negative 1 is negative 3. Negative 3 plus 3 gives me 0. So negative 1, 0, we have a coordinate. And then throwing in negative 2 gives me negative 6 plus 3, so that's going to be negative 3. So negative 2, negative 3. Okay. And it does continue on for all x to the negative direction, so we should have an arrow on the end to show it keeps going. All right, so that's what I mean by chopped off. If I said graph y equals 3x plus 3, like 99% of you are going to do that perfectly. You go to 3, and then you go up 3 over 1. And you draw the line, and it's going all the way through here. But it's kind of chopped off because of the restricted domain. Okay. All right, now the next one. This is just a constant function. Right now we're just focusing on f of x equals negative 2, but under this restricted domain. Okay, so remember it's a constant function. Y is always equal to negative 2. So when I plug in 0 into the function, nowhere to plug it in, we get negative 2. Okay, come up with some other values that fit this domain, right? X is supposed to be greater than or equal to 0. So, values like 1 and 2 or 1 and 3 or whatever you want to plug in there. But the plugging in is non-existent, so we get negative 2, and we get negative 2 again. All right, so at 0, negative 2, we have a closed circle this time. 1, negative 2, we have another coordinate, and 3, negative 2, another coordinate. Wherever you decided to do that, it's a horizontal line. Okay. Now the alternative method, if you don't like the tables, I'm okay with it. I don't care. Here's the other way you can do this. I'd encourage you to write this down, and then from there, try them, and you pick which way you prefer. Basically, we've graphed both of these lines this year without a table at all. So that's kind of what I'm recommending. You just kind of look at this piecewise graph, one piece at a time. So y equals, so I'm just going to call this step 1, y equals 3x plus 3. And then you just got to keep in mind that you only do this for x less than 0. So what do I mean by that? Well, let me just write the second line too. And then if we look at the second line, y equals negative 2. And we just have to keep in mind this one exists only when x is greater than or equal to 0. Okay, jot that down. Then let's go ahead and take a look at the graph and piece it together. All right, so if you graph this using the y equals mx plus b, we would have started at 3. Okay. Then we would have used the slope of up 3 over 1 to continue this line. So then I'd go up 3, 1, 2, 3 over 1, or even down 3 and to the left 1 and create this line just like this, right? My problem is it doesn't exist over here. So I'd have to remember, all right, I kind of chop this line off and put an open circle at 0 and kind of erase the part that I have and just extend it the other direction, okay? Once again, y equals negative 2. We've learned on one of your last quizzes and tests that that is a horizontal line going all the way across here. Okay, so you maybe start by doing that with a pencil. Draw your line, y equals negative 2. There it is. But it can only exist when x is greater than or equal to 0. So then I'd have to chop that off. Okay, so you pick table or the other method. Let's try it for number 8 on your own right now. Go ahead. All right, I'm going to start by just graphing 3x minus 1, but only when x is less than 1. Okay, so I'm going to start at minus 1. There's my y-intercept, and then I'm going to go up 1, 2, 3 over 1. All right, so there's 2 coordinates to start my straight line. And if I was ignoring the domain, I might do something like this and draw my line. Okay, so there it is. However, it's only supposed to exist when x is less than 1. Don't make the mistake of jumping all the way back to 0, though. Some students do that. We want to include 0.999, right? That's less than 1. So we still want to start at the boundary line of 1 right here and just use an open circle to say it can't include 1. So I'm going to erase that part I don't need anymore. I'm going to come right to that spot and put a clear open circle. Make sure that looks obvious. And extending this way. Okay. Now, if you use the table, it's going to match up, right? At 1, 2, we have an open circle because it says less than 1. So that's what we do. At 1, 2, open circle, and then plot these other points, and they're going to match up. Okay. So second line, graph y equals x plus 1 under this domain. Okay, so now I'm starting at a y-intercept of 1, and then I go up 1 over 1. Up 1 over 1 continues that way if you want multiple points, and it's going through here. But it only exists when x is greater than or equal to 1. So now I have a closed circle and an open circle right on top of each other. So basically, you just got to fill it in. I know I can't really tell now, but that's just the way it is because they're overlapping. So this graph goes this way. Another one this way. Okay? They share the same endpoint. Okay. All right, one more I want you to try. None of these are quadratic, and sometimes one of these pieces are quadratic on your OTI and on your next quiz or test. So why don't you add number 9 right here. Here's the function I want you to write. Okay, so f of x is x squared when x is less than or equal to 0. And then 2x minus 1 when x is greater than 0. All right, so for the quadratics, you definitely probably want to create a table for this one. So let me help you get the table going and then see if you can finish this. So for this particular line right here, it's an easy function too, so we should be able to condense this table to something like this. So what are some values less than or equal to 0? 0, -1, -2. Let's keep them small and keep it easy. So what's 0 squared? 0. What's -1 squared? 1. And -2 squared is 4. Okay, so we plot those points. I'm basically going to have like a half parabola or a cutoff parabola for this one. And then we already reviewed this one. Okay, so what I want you to do to finish this is just kind of create another little coordinate plane of your own over here. All right, and then go ahead and label your scale and finish this off. Okay, I'll pause and let you finish this example. Okay, so here we go. X is less than or equal to 0. So we've got these coordinates plotted over here. This one should be a closed circle. I had it open. So I'll fill that in. So then try to curve it a little bit because you know this is quadratic from previous day's lesson. We should show that shape of a curve, half U. Okay, so there's that part. Now 2x minus 1 when x is greater than 0 but not including 0. So it's going to be going to the right of 0. I made a mistake. That's a good example why we should use pencil in math, not pen. I use pen to make sure it shows up easier for you guys. But starting at this y-intercept of -1, this should be open. So I guess maybe I draw it a little bigger. Pure open maybe. And then up to over 1. This is linear. So there's that piecewise graph there, okay? Okay, that'll be it for today. All right, on your piecewise worksheet and in the book on 43A, they're asking you to evaluate piecewise functions, which isn't in this section's notes. It's in the previous section what we worked on. So for example, I'll take you through number 1 on the worksheet. It says f of 2. Notice there's 3 different functions up here. Okay, so when they refer to like number 5, g is 7, I'm using this function. I'm ignoring the other ones. So this says f of 2. For evaluating piecewise functions, you always look to the domain first. So since 2 is greater than 0, satisfies this condition, right? 2 is greater than 0. I use this function rule, not the top one. Okay, and this is just a constant function, so it's pretty easy. I just plug it in and I get 2. All right, I know that one was kind of a weird one. Maybe I should just do one more. Let's try 5, g is 7. Which inequality does 7 satisfy? Is 7 greater than 3 or 7 less than or equal to 3? It's greater than 3. So the only thing I'm using is the bottom line now on this one. Okay, so basically to figure this out, it's 2 times 7 minus 1. And then we get our answer for that one, which is 13. Okay, so pick which function they're talking about and then pay attention to the domains to evaluate the function. Okay, 43 is very similar to that.